We're now going to talk about transformations of f of x equals x squared. And we're going to look at horizontal and vertical shifts using a Desmos demonstration. We're going to sketch the graph of x squared in one color. We're going to make a second graph in which the graph g of x is in another color, and we're going to write the equation of g of x. And then we're going to add another reflected and shifted graph in a third color. Open up Desmos. I have it open. I'll give you a second. Go ahead and pause the video. I made a graph. How I made these little shifter bars, which they're kind of nice if you want to see how things are changing. I'll show you. Just write the equation. F of x equals a parentheses x minus h squared plus k. And you can add sliders for your coefficients a, h, and k. We were asked to shift, and I wanted you to see how shifting occurs. And so you can just mess around with k, for instance. And k is the number on the end. And if we increase k, you can see what's happening. Our graph is shifting up, and if we decrease the k, the graph is shifting down. So this equation right here that I have written is g of x equals, my a term is a 1 right now, and I have x minus my h term is currently a 1, and then I have my k term is -6. So that's the equation that I have made. And I can also, if I wanted, I could shift over to the left and to the right, you see that moving there, by adjusting the h value. Again, the k term takes things up and down, and then the h term is taking things left and right. And so this one is currently in vertex form. In the vertex of this one here, you can see right there, it is the point 1, -6. And you can see the 1 and the -6 in the equation. And they asked us to do one more thing. What was that? Add another reflected, shifted graph in a third color. And that one's supposed to be h of x. Not a problem. What we can do there is you can adjust the a term. And you can see as a gets larger, that graph that I'm adjusting is getting skinnier. As it's getting smaller, it's getting wider. Oh, so wide. There's 0, not very parabolic. But if it goes negative, it goes upside down. It becomes reflected. Larger A's, skinnier. Negative A's, upside down. So let's get that h1 in there. They said they wanted a reflected graph, so that would be h of x equals -0.4x minus 5.1 apparently squared, and my k term is -3. So I'm going to bring my f of x back to where it started, just so you can see where we started. 1. Why do I have an exclamation? Oh, I've defined h in more than... Oh, okay. It didn't like that I used h here. So I'm going to make that j. There we go. Now, bringing everything back. That is where we started, more or less. We started here. When we talked about how you can shift things to the left and to the right, and that is by adjusting the h and then the k, the up and down, left and right, and a takes things and can reflect them. Those are the basic transformations that you can do. And the nice thing about the vertex form is it shows you those transformations. The a term shows you whether it's upside down or right side up. The h and k term tell you that vertex point. The a term also kind of tells you how wide things are, but we'll get into that in a while. All right, I have another question for me to do apparently. So with this one, it's telling me that my vertical shifts are on the end of an x squared equation. Yeah, If it's negative, I'm going down. If it's positive, I'm going up. That's nice. My horizontal shifts, my left-right shifts, are a little trickier. If it's negative, I'm going to the right. A lot of folks get this one mixed up. And if it's positive, I'm going to the left. Identify the vertical and horizontal shift of g of x. Okay, so what I'm seeing here is that my h term is -1 and my k term is -4. A lot of folks would say that it was +1, but again, the standard form is x minus h squared plus k. So keep that in mind. So we are going to be comparing it without graphing. That's okay. I can do that. I'm looking up here and it says that that would be a shift that is right 1 unit. And then the k is negative, so it would be shifted down 4 units. Fair enough.